The basics of algebra. Simplified algebra forms the backbone of mathematics, offering a powerful toolkit for solving problems and understanding patterns in the world around us. Here's a simplified overview of its basic principles. Understanding variables and constants. In algebra, variables like x and y represent unknown quantities or values that can change. Constants, such as numbers like 2, 5, or pi, remain fixed and do not change. Expressions and equations. Algebra uses expressions and equations to describe relationships between variables and constants. An expression is a combination of variables, constants, and operations like addition, subtraction, multiplication, and division. For example, 3x plus 5 is an algebraic expression. Equations, on the other hand, involve expressions separated by an equal sign. For example, 3x plus 5 equals 11, indicating that both sides are equal. Solving equations. The goal in algebra often revolves around solving equations to find the values of variables. This process involves isolating the variable on one side of the equation. For instance, to solve 3x plus 5 equals 11, subtract 5 from both sides to get 3x equals 6, and then divide both sides by 3 to find x equals 2. Linear equations. Linear equations are fundamental in algebra and involve variables raised to the power of 1. They can be written in the form x plus b equals c, where a, b, and c are constants. Solving these equations typically involves basic arithmetic operations. Graphing linear equations. Graphs visually represent linear equations on a coordinate plane. The equation y equals 2x plus 1, for example, forms a straight line when plotted. The slope 2 in this case indicates the rate of change, while the y-intercept 1 shows where the line crosses the y-axis. Quadratic equations. Quadratic equations involve variables squared, for example x2, and can be expressed in the form x2 plus bx plus c equals 0. They often represent parabolic shapes on graphs and can have one or two solutions, depending on the discriminant b to 4ac. Applications in real life. Algebraic concepts are applied across various fields, from physics and engineering to economics and computer science. They help model real-world scenarios, predict outcomes, and optimize solutions. Conclusion. Mastering the basics of algebra provides a powerful foundation for problem-solving and understanding relationships in mathematics and beyond. By grasping these fundamental concepts, you can navigate more complex mathematical challenges and appreciate the elegance of algebra in everyday life.